Welcome back, everybody. So this is video 3 of the graphical user interface for video games that we're going to be making. Again, this is going to be a series about making video games, making the different types of video games: Atari video games, Nintendo video games, DOS video games for the web browser, making them in JavaScript. But before I made any of the games, I wanted to build a graphical interface that I was going to reuse across all the games. So the graphical user interface, takes care of putting little buttons on the screen that we could click on, making the dialog boxes, making sure that the game looks the right size in all the devices, whether you resize your browser or whether you're playing it on a mobile device. So we decided on making the game based on a library called TurboVision, an old library, just because I had the manuals. So to get up and running and start making games, I don't want to implement the whole library. I just want to implement the essentials that I need to get up and running right away. Then I'll build the library as time goes along. To get this interface up and running as fast as possible, I gotta pretty much implement this. Hold on a second. I gotta implement this T application. T application is the highest level object that we inherit from, that we descend from, to make all our games. But to make T application, we have to make the object called T program, because T application inherits from T program. To make T program, we got to make T group, because T group program inherits from T group, and so on and so forth. So we got to make at least, to get up and running, T application, T program, T group, T view, T object we already made. And also we want our games to have some dialog boxes. So definitely we want to implement T dialog. And to implement T dialog, we need to implement T window. So pretty much all the objects on this hierarchy here, we got to implement to, in a minimum, to have a functional graphical user interface for our games. We also have to implement things like T button, so we could make clickable buttons, and T image, so we could have the images. So this is a clickable image, this thing here. So when we click over it, when it's displaying on the screen, it is actually just displaying the image. When we click over it, it makes the image a little bit darker. Depends on the browser. In different browsers, in the Internet Explorer, it makes it transparent. And when we click on it, it pops up a window, and the window has some text, some buttons that we could click on, etc. So in order for us to get this up and running, we got to implement at least this tree here. T application all the way down to T object. T object we've already made. So hopefully we could speed things up and make T view, T group, T program, and T application. So we could have a functional interface that we could descend from. T object we've already made. Now I've told you that we're going to inherit this from. We're going to take existing code from the internet, because TurboVision is already open source and it's in the internet. Somebody already remade that, so we could just take that code and modify the code to work in JavaScript. So what I'm going to do is I'm going to try to speed things up a little bit, and I'm going to try to get at least these 4 objects done, so we could have a functional graphical user interface, and we could start making games as soon as possible. Okay, so since our first step to converting, again, we're not going to reinvent the wheel here. TurboVision is already a code and a library that is available on the internet. You could do a search for it, and we found already the source code. So our first step in creating our JavaScript vision is to take the existing TurboVision code and convert it over to JavaScript, and then make the modifications we need. So I said that we needed to make at least, let's go here. at least this guy, T application, T program, T group, T view, T object we already did. So we have to take T view, T group, T program, and T applications and convert that over to JavaScript minimum. T application, I'm not going to use the existing code that we got from TurboVision, only because the manual here indicates what the code is. It's just a constructor code that initializes the memory, the video, the events, the system, the history, and then it calls the constructor of the T program object. And then there's another one called the destructor, which does this in reverse. It calls the destructor of T program, and then it does done history, done system, done event, done video, done whatever. Since all of these are very specific to the platform that you're developing under, I'm not going to copy that code from the code that I downloaded of TurboVision, because that's very system specific. So what I'm going to do is just what I did was I just created a T application file which is empty, and I'm going to create my code based on this information from that I got from the manual, which should be simple enough. So since I already created that, the code that I'm going to copy over from the TurboVision code is T program, T group, and T view. These three right now I'm going to copy over. Those three should give me enough to, well, I'm going to want some dialog box, so I'm going to also copy T desktop, T dialog, and T buttons, because I want some buttons to press on it. I'm going to copy a few others, but from now, the minimum, T application, I created an empty file because I already know the source code that I showed you down there. I'm going to copy T program, T group, and T view from the TurboVision source code. T program, T group, and T view. Okay? So I'm going to go to my download. I'm going to look at the TurboVision code, the classes, T program, T program is here. I'm going to copy it. I'm going to paste it here. T group. T group is here. I'm going to copy it. And T view. I'm going to copy that. Later on, I'm going to copy T dialog and T buttons and that, so I could actually do some dialog windows. But for now on, I've copied these three objects: T group, T program, and T view. T application I already have. And I'm going to convert this from the TurboVision code over to JavaScript. Now, I'm not going to show you how I'm going to do this, because I already showed you in the previous video how I did this, how I do the conversion. So I'm just going to convert it, and I'm going to cut over to that point for sake of not making this video too long. So I'll come back to you as soon as I convert this code, and then we're going to talk over. I am going to explain the code that I had to modify from the original code to work on the JavaScript web browser platform. So that those specific bits of code that I had to modify from the original code to get it to work in the web browser, I will cover. So after I convert it, we'll continue this video. Okay, so I converted all the TurboVision code over to JavaScript. That's why I call them T application PHP, T group PHP, T view PHP, etc. because I converted it over to JavaScript. I created an extra object that I didn't mention earlier on my list. It's called T-Event. I converted over this extra object, not completely, because it's using TView. So I had to implement that. I'll show you what I implemented. I didn't implement almost anything. I just did the basic. But the first object after T-Object that we have to implement is TView. So let's go to TView. So here's TView. TView uses T-Event, so I have to implement T-Event. It uses the object, uses T-Rect, T-Point, it uses some of the basic object. So this is pretty much a conversion from the TurboVision code I downloaded from the internet. I'm gonna make this code available. I'm gonna put a link in the description of all my all the videos for the graphical user interface that I'm building. So you'll be able to get to this code on GitHub. And I'm also gonna put a link to the TurboVision manual so you could get the specifications to all the objects. But basically this is a straight conversion. I showed you how I converted. These are all the variables. This is a constructor object. The constructor object inherits from T-Object. These are all the fields. It has an owner field, an X field, origin field, a size field, a cursor field, etc. The state field. I added some extra fields because this is, like I said, this is not exactly line by line a conversion, because the TurboVision was made for an operating system. This is being made for the web. I added these 3 extra fields. Content. So if since TView, what TView does is draws a rectangular region on the screen where we could draw and write to. Content is just a field where we could put any content we want to put on the screen. There's other ways of doing it here, but I just decided to add this. I'll probably remove it later on when I've implemented the whole library. But for now, I just wanted to have this flexibility. The style field, so we could set up the style of how this region is going to look, and the class field. I did this because I needed this flexibility for one of the games that I made. So I've added these 3 extra fields. I'll explain more about this later. So there's a lot of fields. Like I said, you could go through the manual later on of all the objects, which I'm going to put on the link. But there's a lot of methods. There's one called handle methods. This is a very direct conversion from the code that I downloaded. So I'm not going to explain every code, all the code, because I'm going to put the manual on the web. What I'm going to explain is the changes I made. So pretty much all the code remained the same. I just converted over to JavaScript. I made a few changes. The main changes that I made is the draw method. Since the draw method for TurboVision drew to the screen, and when I drawing this, we're drawing to the browser, I had to modify this code. So let me explain this code. When you call this code, it does something. The first thing it does, let's go below this, is it creates a div that it's going to draw on the screen, a div with an ID called view and a number. The number is this ID, the unique ID that I got. So it's going to be view 1, view 2, view 101. It's going to create a unique ID called view plus the ID that the object gave this class. It's going to have the class fields, which I could pass over. It's going to have a style from a style function that I created, which I'm going to show you later. This is not part of the TurboVision. I added this for flexibility. And I also created a function called other. So it adds any additional fields, which I may not have thought of right now. Again, all of this is for flexibility in the code. And then it draws initially the div with this content, that's the content field I created in the top, plus any additional content I might pass when calling when calling this function. That's the first thing it does. Now, when it draws this div, the first time it's going to check, does this object has an owner? If it doesn't have an owner, it's going to draw to the body. Drawing to the body is kind of like drawing to the top level of the screen. So it's going to draw my div directly to the body. It's going to insert it in the body. Or if this has an owner, it's going to draw the div inside the view of the owner. So I'm going to get the element by ID of view plus the ID of the owner. And I'm going to draw inside of it the div that I created. Now let's say I've already drawn the div on the screen and I want to update any content. What this code up here does is first it checks to see if the div has already been created. So it does get element by ID, view this div, and it's going to say if it's not null, that means if there's actually an object called view with this ID, just update the content, update the content, update the style, and update the class information, and then exit out of here. So simple. So this is what draw does. So draw is broken down into 3 steps. It creates the initial div if it hasn't been created before, and it draws it to the main body of the document, or it draws it inside another div of if it has a parent object. And after it draws the div, in the future, it doesn't have to do this anymore. If I want to update any content, I just insert it directly to this div itself. Okay. And this other code converted straightforward from the 12 revision code. So I created a function called style. This is for flexibility again, so we could change the style of what we draw on the screen. The initial style says that the position of this div is going to be absolute. The overflow is going to be hidden. So that means if we draw a box on the screen, and we draw an image inside that box, and the image flows out of the box, it's not going to be shown. It's going to be hidden. The display is going to decide whether to display the rectangular region I did on the screen, depending on the state. There's a field called state, and it has different properties. One of the properties is if the object is visible. And then also its position on the screen. So it says the left and the top position is dictated by the origin point object, and the width and the height of the window is dictated by the size object on the of this object. And the other object doesn't do anything right now. It's just an empty string, but we could actually use it a little bit in some other classes that I derived from this TView. I had to implement this T-event. T-event, I really didn't implement much of it. T-event is where we send, like, if you press the mouse button, or if you press a keyboard, it generates an event, and these are the various types of events. There could be a nothing event, which means nothing happens. It could be a mouse down, a mouse up, a key down, a key up, or you broadcasting a command or sending a message, or these are kind of like the different types of event that there could be. I was supposed to implement 2 objects, the getMouse event and the getKey event. I didn't implement it right now, so I just put this note here that it has to be implemented. Now, so far, like I said, I converted the TView object from the TurboVision source code, and I just modified this bit of the code. I modified draw. I added a style function and another function. I also modified this set state. Set state, you set different state properties of this object, and one of the property that you set of the state if it's visible or not. Now this is the code straight copied from the TurboVision source code, except I modified one line. This line here, this two line. If the object is visible, what I do is I say set is display to black, means make it visible on the screen. The original TurboVision code, I think, code another low level object which actually drew the object on the screen. Since we're not doing that, we don't have to draw the object every time we set it visible. All we have to do is just pretty much tell style display black or display none, and that sets it or hides it or displays the div that we created. So this is what I modified in the set state. The set state, instead of drawing the whole object on the screen every time we set it visible or invisible, all I did was I called the object by getElementById, and I set it to display to black, which means makes it visible, or if it's invisible, I say set display to none, which makes it invisible. The rest of the code is pretty much the same code from the TurboVision. Okay, so now that we've done this, well, I've described TView and TVent, not in detail, but again, I've already explained how in a previous video, how I convert the TurboVision code over to JavaScript. Let me test it out. Okay. Okay, so we're going to use TView. And in TView, let's just draw a few things on the screen, okay? So I'm just going to create an array called V for view, and I'm going to set it to empty. And I'm going to create a loop. Okay. Okay. All right. So let me explain this. So I'm gonna create 10 items. I'm gonna go from 0 to 9, uh, and it's gonna create 10 T views. I'm gonna pick 10 random points on the screen at random, to 10 points in the screen at random, and I'm gonna draw a rectangle which is from the beginning of that point to that point plus 100 in the X and Y direction, and then I'm gonna draw on the screen the word more stuff. Okay, so simple. So this should display the word more stuff at random in 10 different points in the screen. So let's go to that. Okay, I didn't draw anything. Let's see what's going on. Okay, I forgot a rect. Okay, this one bracket, two brackets. It's got two brackets. Okay, so let's redraw that. Okay, so there we go. It says more stuff here, more stuff there, more stuff, more stuff, more stuff, more stuff, more stuff, more stuff. So it says more stuff at random all over the screen. Perfect. This may not seem like a big deal, but this is the starting point for other more complex object, which is going to be very useful in the game. So pretty much what TView does is this. It creates a rectangular region on the screen, and we could draw or write stuff to the rectangular region. But it has a lot of other properties. It has the ability to communicate with other objects. It has the ability to set different states of the object. It does a lot of stuff. So let's say we want to create an object that inherits. We could say, let's say we want to put a frame around it. I could create an object. Let's call it box. It inherits from TView. It displays on its in itself. The word view. Plus the ID. And of course this is inherited from TView. Now let's just say one thing that I wanted to be different from the default is that I wanted to have a kind of rectangle around the window. Okay. So right now I'm creating a style. I'm calling the style function with this call, and it's gonna take the default property of the TView style, and it's gonna add to it the border 1 pixel solid. So it's gonna create a border that is 1 pixel thick and that is solid around it. All right. So I've created this object called box, which inherited from TView. The only difference is it's gonna have a border around it. So let me change this thing around. Sorry. Okay, so instead of calling TV, I'm gonna call T-box. Everything should remain the same. It's gonna display a box around it. It's also gonna display in the content the word view plus the ID. And then in addition to that, I'm gonna draw the word more stuff to it. So let's see what this does. So it should create a whole bunch of regions on the screen with boxes and the word view plus the ID plus the word more stuff. Let's see. Okay, again, no problem. Let's see what happened with the code. Okay, 1 second. Okay, I made a mistake here. Okay, so let's try it now. So there you see, it has a rectangle. It has the view plus the number plus the word more stuff. This let's close this down. So here's view 1, here's view 2, here's view 3, here's view 4. So it displays it displays the word more box, and it displays the rectangle. So perfect. So now we created a view. The view allocates a space on the screen, and we could draw right to it. This is the starting point for all our graphical objects in JS Vision, which is a descended inherited. It's derived from TurboVision. Okay. Okay, the next object in the hierarchy is T group. T group, as its name implies, takes other objects and groups them together. This is very useful because often you want to like if you have a dialog box, the dialog box is made up of buttons, of windows, of different views of different things that are grouped together. So T group is actually a very useful object that we're going to be using a lot. I did a straight conversion. All this code is pretty much just the TurboVision code converted to JavaScript. The only thing I modified was I added an array code list. Now in the original TurboVision code, T group manages the objects that it has using a linked list. And it does this by using these two variables, the last and the current. It has a linked list of objects, and it manages them using those variables. I noticed that a lot of the code in T group was replicating the code that already exists in the JavaScript array. So I decided to use an array because I figured it would be faster than code that has to be interpreted by the JavaScript engine. This is built-in code, so I'm assuming it's optimized, so it's going to be faster. So what I'm doing is I added this list object, and this is going to hold all the objects that the group is going to manage. Instead of the linked list, is going to be just a simple array. So again, all these values are the default values set by the TurboVision code, which I just straightforward converted. I added this list, and I also modified two bits of code. I modified draw. Let's go down to draw. Here's draw. I believe this is the original code of draw. Get clip rec redraw, which redraw doesn't do what we want it to do. This is very system specific, and get extend. I modified code to simply just draw the current object, draw itself, and then draw every little sub object that it has in the array list. Simple. So first it draws itself, then it draws all the objects that it contains in the list. Besides that, I modified the code insert. Now, how you add objects to group, you call the function called insert. See here, it has a for each function in TurboVision. This is built into to the arrays in JavaScript, so I'm assuming it's going to be much faster a built-in function than me writing my own function. Here, insert. I also modified insert. Now, insert in the original TurboVision code calls an insert before a function, and this function depends on the linked list array. You know, you give it the current object, it finds the first object in the linked list, and it does and executes some code to insert it. I modified that to this code down here. Now, what I did simply, if you want to insert an object, it pushes it to the end of the list here. It takes the list and it pushes that object to the end of the list. It sets its owner, it sets the owner of the object to this object, because this object is going to be the owner, and if it can, it tries to draw the object right away. That's all. Also, it checks before doing that if I pass it a null object. If it's null, I just exit. I don't do anything because I don't want to insert nulls to my list of objects. So that's pretty much the two modifications I made from TurboVision. I also added two functions which I don't expect to use a lot. I added a function called push and unshift. Why? Because the JavaScript list, the JavaScript array type has a function called push, which you could push the items. Well, I created one where I could give it a list of objects, and it pushes all of them to the end of the array, or you could give it a list of objects and it pushes all of them to the front of the array. If you want to put it at the beginning of the array, you call unshift. I don't like this name, but that's how JavaScript named it. Unshift puts all the items that you give it on the list to in front of the array. Push all the items that you give it to the end of the array. So that's pretty much the only modifications I made to T-group from the TurboVision code. So let's just test out the T-group code now, okay? Second. Okay, so we're going to use T-group. And let's say in T-group, I just want to create another object. Let's copy this. Let's erase this. I want to create another object. Let's call the object group. It's going to inherit from T-group. And let's say since T group, what it does is manages other group of objects. Right now, the only visual object that I actually created is T view, which I've inherited in this box sub object that I created. So I'm just going to insert 3 views into my group. Let's insert the first one. Okay, so I created an object called group, which inherits T group, extends T group, and in that group I've inserted 3 little boxes. Okay, a box at 10, 10, 20, 20, a box at 0, 20, 10, 30, and a box at 30, 20, 60, 30. So it's pretty much going to create 3 boxes on the screen. So it's going to Okay, so we're getting closer to finishing up the tree that I showed earlier. We're up to the object T program. Now again, I copied over I just converted all the code from TurboVision over to JavaScript, except I made some modifications. The constructor of T program, what it does is it actually determines what the resolution of the screen is, and assigns that resolution to this to the bounds of this object. I'm not going to do that. I'm going to, because different browsers have different resolutions, and if we write a game, we want the game to look pretty much the same across all devices. You know, if you have it in a in your laptop computer, if you have it in your cell phone browse, if if you're running it from your cell phone or your laptop or from whatever device you're running it, all the resolutions are going to be different from different devices. So what I did was actually that you specify the width and the height of what you want the program to be, and I said the bounds, the size of the program to the width and the height that you specify. Now, in this program, it's just going to set it to the width and the height you specify. So if you want it to be, ideally, I pick 960 by 640 because that kind of fits all the devices best. But if you want to be whatever size you want it to be, you tell it. And I don't do it here. I do it in the next object. Then what we do is we scale the application up or down to best fit the actual resolution of the device you have it on. So if I have it on my browser, and my browser, I have a full screen, and I pick the program that it only takes a little region on the screen, it's gonna scale it up to take up to the whole region. Now it's not going to do it in T program. It's going to do it in the other object, the higher object, which is the application. But at least in this object, we specified the ideal size that you want your program to be. So you give it width and the height, and instead of us calculating what the width and the height is based on your browser, which we could do that, what we do is actually we just set the region to extend from 0, 0 to the width and the height that you specify. Another thing that I modified is the init screen function. There's an init screen function, and it does different things to initialize the screen. I'm not sure what the original code was. What I set it to do init screen is just basically just draw itself to the screen. That's all it does right now. The original code breaks down the screen into 3 regions: the status line, the menu bar, and the desktop region. And there's some code implemented in TurboVision for this. I haven't implemented that code at all. So right now, all I do in its desktop, in its menu bar, and all of that, what I do is I return null. I just return a null object because I haven't implemented that part of the code yet. In the status line, I was beginning to implement the code from TurboVision, so I have that commented out. But right now, what it does is just return null. It hasn't implemented anything. So that's pretty much it. It's just a simple object that breaks down the screen into 3 things: the status line, the desktop, and the menu bar. Those 3 things I have not implemented, so I'm returning null. It sets some state for this object, and it sets the bound to whatever you want your application's resolution to be. So you actually give it the resolution. So let's test this out. This is a very simple one. In the next object above is where we're going to do a little bit of making sure that your program or your game, because not everything that what I'm going to do is going to be a game. I'm going to make some programs so I could build some tools to actually make it easier to make other games, since I plan to make a lot of games. That extra code is going to get implemented higher up. Okay, so right now, that's pretty much what I did. I just converted the TurboVision code of T program, and you specify the width and the height of your application or your game or whatever, and that's what it's going to be. So let's test this out. This was a very simple object right now. It'll get a little bit more complicated later on. Okay. So in the last example, we had a group. It's going to be very simple, similar to the group. Right now, we're going to have a program. It's T program, the object, and we're going to keep this box from the last example, and we're going to, let's just say, call a function game. And it's going to extend T program. And T program expects this for us to give it the width and the height. Now I picked 960 by 640. That's what I'm going to pick most of my games to be, because it looks pretty good on my cell phones, and it also looks pretty good on the browser. So that's kind of like the resolution I'm mostly going to pick. Let's get rid of this. Extend game, T program. Now let's start using things the proper way. The proper way of writing to the screen is either writing it to the desktop, to the menu bar, or to the status line. So since we're just going to write to the regular portion of the screen, we're going to write to the desktop. So let's overwrite the desktop method. I did it with a capital I, but I'm probably going to change that later on to a lowercase I. But for now, we're just going to leave it with a capital I. There's a variable called desktop that we created in programs, which is going to hold a pointer to the desktop object. So we're going to use that. There's a method called getExtend, which we got from porting over TurboVision to this to the JavaScript version. And basically, we'll getExtend. You could pass it a variable, and it'll fill it up with the size. Pretty much, the size is 0, 0, 0, comma whatever width and whatever height I gave it. In this case, 960 by 640. So the desktop, I'm pretty much saying to make it take up the entire screen. getExtend gives you the bounds of the entire screen. Okay, so pretty much what I'm gonna do, I'm gonna create 10 boxes, and they're gonna pretty much one is gonna take up, make a box from 00 to 950 to 630, and then it's gonna go shrinking it by 10, but moving it to the inside. So the next box is gonna be 10 by 10. Starting at 1010, the next one is going to start at 2020, 3030, etc, etc, and it's going to shrink the size by 10, 20, 30, 40, etc. So I'm just creating some boxes, and then I'm inserting them into the desktop. In the desktop, I say pretty much take up the entire screen region. So calling this should pretty much just create some boxes on the screen, and the boxes of course say view plus the ID. So let's just create an object of this game. So we're creating a variable game of type new game. Game initialize calls program, which creates a region of 960 by 640, and like I said, program inserts the menu bar, status bar in the desktop, and we're just making sure that in the desktop region we have some boxes drawn. Okay, so let's run this and let's see what we get. We should get some boxes, some squares. So there we go. It's created some squares, getting inside of each other, getting smaller. That's what it's supposed to do. Now, right now, I gave it the screen size. I said it was 960 by 640. That's a fixed size. If you see there's some extra white space here and some extra white space there, that's because it's not scaling it to the specific size. Also, if the region was smaller, like if I had a small region, it just makes the box still 960 by 640. Our next object is going to take care of scaling things up and down. So if like we have a small window and we say that the game is 960 by 640, it's going to scale the game down to take up the window screen. So it'll look pretty much the same on all different devices. So if you have a cell phone with a small screen, it's going to make sure that the entire region shows, so that it doesn't get cropped, cut out like this. It'll scale it so that the entire game shows. If you have a tablet, it'll scale it to the tablet, which will be bigger. And if you have your browsers, it'll scale it to the browser. So it'll make sure that it'll fit the screen on all different types of devices. That's going to be our next object. So right now, program was just a simple object descendant from T group, where it has three regions: menu bar, status bar, and the desktop bar. Now I haven't implemented any of that, so there's no menu bar here or no status line here or anything like that. Okay, so we are at the top object in the hierarchy. We are here at T application. T object was the first object we implemented when we first started making this video. In this video, we implemented T view, T group, T program, and now we're implementing T application. T application is a simple wrapper compared to the rest of the object, but we have to implement ourselves. What it has is just a constructor and a destructor. The constructor, what it does is call a function called init memory, init video, init event, init system error, init history, and then it calls the constructor of the program object. And the destructor does the same thing in reverse. First it calls T program done, and then it calls the done for history, system error, event, video, and memory. So I didn't have to convert any TurboVision code over, because it's pretty much, this is the entire code. All these little functions here, we have to implement ourselves. So let's go to the code. So the constructor is called T application. I passed it the width and the height because I decided that we were going to specify what the width and the height of our game or our program is going to be. I also added two extra fields called overflow width and overflow height. The reason I added this, let me show you, is because often games won't fit perfectly in the browser size, in the screen size, and it'll have some extra spaces left over which are black. Like here, if you see, the game is 960 by 640, so it goes from here to here. It has a little bit of extra black space on the top and a little bit of extra black space on the bottom. I don't care about the top and the bottom, but in games like this, with a side scroller, I don't want extra black space in the left and the right. I want it to fit the screen entirely as possible. So what I did is I created a little padding region. Let me show you. See, now here the browser is actually a lot longer than it's higher. So to fit it, it does its best. It scales it down to this size. So this is actually the size of the game. From here, from this icon to this score box. So this region here would normally be black and black, but I don't want it to be black. I want it to take the entire screen, the game to take the entire screen. So I created two variables which create an extra padding area, which will extend the screen size there. So I gave it a 256 pixels extra here, 256 pixels extra there. So if you resize your browser, it'll still show it on the game. It's actually not perfect. If this becomes big enough, it'll still show a black region. So let's make it even smaller. See, it's even smaller. So now it's actually a lot wider than it is higher. So since it tries to fit it, it actually ends up showing some black region in the left and the right. But for most browsers and most mobile devices, it'll show a full screen, so it'll look good. Okay, so that's what the overflow width and the overflow height variable is. It's an extra region that we create around our game to show the game world, so it'll fit most devices perfectly. So what the application does, it calls memory, it calls video, init video, init event, init system error, init history, and then it calls the constructor of T program. I added this bit of code here to make it better on mobile devices. I insert a bit of code on the screen. I actually insert an image right now with an ID of rotate, and this is going to display on the screen an icon that is going to tell you to rotate your mobile device in the orientation that best fits the game. Right now, I'm giving it a null image, a transparent image, so it doesn't display anything. Let me show you. Hold on a second. I created in my website, in my web server at the root directory, a folder called image. So you should create a folder called image at your web server. And in this folder called image, I uploaded 3 images. A 1x1 pixel transparent image, so it doesn't display anything, and an image that tells you to rotate the game sideways or to rotate the game upright. Hold on a second. So by default, it doesn't display anything. This is an invisible pixel. But if you have your browser, if you have your cell phone upright, but the game looks better sideways because it's longer than it's higher, it's going to display this icon on your screen telling you to rotate your cell phone sideways. In the same hand, if you make your game taller than wider, and the game looks better with the cell phone standing up straight, but you have your cell phone sideways, it's going to display this icon on the screen telling you to rotate your cell phone from sideways to upright. Okay? Okay. So that's what it's doing. To do this, I'm actually going to create an object called TImage, which allows me to insert images on the screen. But since I haven't implemented that code, what I did was I created a simple object called TWrapper. And what TWrapper does is injects any HTML code I want to on the screen. So TWrapper, you pass it a string. I'm passing it this string with an image tag, and it inserts it on the screen. So right now what I'm saying in TWrapper is place this on my website. An image with an ID of rotate that is displaying an all image right now, with its position being absolute, its index being 999. 999 pretty much I'm giving it a very large number, so it'll always be on top of the other numbers of the other images. And the origin is going to be the overflow width and the overflow height, the overflow X and the overflow Y. I'm also adding a bit of code at the end on my T application that is going to check if this is a mobile device. If it's a mobile device, it's going to wait a few milliseconds to allow, if you rotated your screen for the new orientation to take effect. I'm waiting a few milliseconds before I update the screen. If it's a regular browser, I'm going to update the screen right away. What update the screen does is actually it's going to center your game on the browser, and it's going to scale it to best fit your browser. So it'll look the same on all games. Like I said, let's go back here. This my game is 960 by 640. This game, but the screen is actually bigger than that. So what this did is scaled it up to best fit the screen. If I make my browser smaller, it scales the game down to best fit the screen. So what the update screen function does is that every time you resize the screen or you change your orientation on your mobile device, it rescales the game so it'll best fit the entire window, like it's doing here. So let me just put this back up. Okay. So initialize memory, I really don't have to do any memory initialization because JavaScript has garbage collection, so it should take care of releasing memory and initializing memory mostly on its own. I'll see if I have to implement something in the future here, but right now I'm not doing anything with this function. Initialize video. This is where I actually define the overflow region, if any, and I take the aspect ratio of the screen. Taking the aspect ratio of the screen will help me determine what the best orientation for it is and how to scale it. I set scale to 1 right now. I'll explain that in a minute. And I added a few listeners. I added a listener called Unchanged Orientation. So on your mobile device, if you rotate your cell phone from upright to sideways or from sideways to upright, it's going to call the update screen function, so it'll update the screen for the new orientation. Or if you resize your browser, either on your mobile device or on your regular browser, it's going to call the update screen, so it'll resize the game to fit the new dimensions of your browser. So I added this to event listener that is going to call this function. The function that is going to call is update function. Now, what does update function does? The first thing that update function does is it checks what your browser size actual screen size is. I do this by calling Windows inner width and Windows inner height. So actual holds up the dimensions of your actual browser size. Then what I do is I try to see what I have to scale my game to, so it'll best fit this screen. So let's say my actual screen size is 100 pixels wide, but my game is only 50 pixels wide. Then the aspect ratio is going to be 100 divided by 50, which is going to be 2, meaning I have to scale my game up to twice the size so it'll fit the new screen. Basically, so scale is going to tell me what to scale my game up or down by so it'll best fit the screen. Okay. Now I could scale it by checking the width or the height. What this part of the code does here is if it figures out which best to fit it by. It checks if the ratio of the width is less than the ratio of the height, then we are going to scale it by the width aspect ratio. Otherwise, we're going to scale it by the height aspect ratio. So this determines how we're going to scale it by the ratio of the width to the actual width to the actual height, or the actual width to the game width, or scale it by the actual height by the game height. The real aspect ratio is the aspect ratio of your actual browser screen. We're going to use this to determine how we're going to have to rotate the game, if we have to rotate the game at all. So what do we do? Once we have the actual screen size, and once we have what our game size is and what we have to scale it with, we center it. Internal actually holds the kind of the origin point of where we have to center the game. We do this by this calculation. We take the actual screen size and we subtract the total screen size. Now the total screen size is the screen size plus, this should be plus, the internal is the actual screen size minus the scaled up total screen size. The total screen size is the game screen size plus twice the overflow region I gave it. It's twice the overflow because when we give it an overflow, it has an overflow either on the left and the right, or on the top and the bottom, in those two endpoints. So it's twice. Once we actually have the actual screen size and the scaled up total game size, we take the difference and we divide it by 2. That gives us our origin where we have to put the game so it'll be centered and scaled up to the size we want it. That's where we go to call a set transformation. What set transformation does is it calls a function called translate, which it moves the origin of the game. Now it moves the origin of the game to the x and y position that we calculated with the formula above, and also it scales the game up. It scales it to the ratio that we calculated was the best ratio to scale the game up. This set transformation, it's a function I created, which is under a file which I call utilities. What utilities does, it just holds miscellaneous functions that I created that I'm going to use throughout the game. So let's see what utilities holds. Okay. So utility just holds miscellaneous functions, reload the screen, check whether a file exists on the website, include a file from the website in a web page, mobile device. It checks whether the device that you're running your game on or your application is a mobile device or not. It does it right now by checking for these strings in the Navigator user agent and some other functions. The function that I'm using right now, which is set transform or set transform origin, this is a bit of an old function. In the old days, set transform was not a standard function or set transform origin. Some old functions just kind of defined it as WebKit transform or WebKit transform origin, and the other functions we had a standard just defined it as transform or transform origin. What this code does is it checks which function is defined in your browser. Today, I believe that all of them should be defined regularly by calling transform and transform origin. So I might change this code later on, but for now, I'm leaving it this way because it works. It checks for very old browsers to see if the function was defined as WebKit. Okay, so perfect. So we have this code. What the code does is it scales the game up and it sets the center set on the screen. Scales it using this. It centers it using this equation, and it scales it up using the best scalar function that we could come up with. Now, the last thing that we're left with is it checks if we're running it on a mobile device. It checks the real aspect ratio of the game compared to the aspect ratio. It determines if the game looks better sideways. It'll display an image on the screen telling you to rotate the game sideways, or if the game looks better standing upright, but you have it sideways, it'll display an image on the screen telling you to rotate your mobile device upright. So again, what this does is it checks the orientation of your game if it's a mobile device, and if you have it in the orientation which is not the best orientation for the game, it'll display an image telling you to rotate it in the other way. Okay, so now that we've done this, let me see if I explain this also. Init event. Init event, what this does, it initializes different events. Mobile device, you have something called a touch move. I don't want that to be captured in our games. So what I created a function that prevents its default action. And what I added was an event listener for when you press the key down. When you press the key down, what this does is it creates an event for it, calls event key down, and captures the key code, the key and the key code of the key that you press, and it sends it to a function called handle event. Handle event pretty much handles all the mouse and keyboard inputs in our library. I haven't implemented handling the mouse event, handle mouse down, because right now I just do it the regular way that it's done in JavaScript and in HTML. I don't do it the Tovo Vision way, handling the mouse. But in the future, I'm gonna have to add an event for mouse down, so it'll handle the mouse event also. But right now, the only thing that is capturing the initialize event functions is when you press down on a keyboard, it captures that key that you press, and it sends it to handle event of the application function. Okay, so now that I've explained this code, let's test it out. Let's see. So in our last example, we created some boxes using the T program. Right now, we're just going to change it to use T application. So it's going to go up one object higher on the hierarchy. Everything is going to be pretty much the same, except instead of calling TA program, we're going to call T application. Okay. So once we've done that, in the last, this is showing the last example. In the last example, we created some squares. Now, if you notice, it puts the game here at the corner, left top corner of the screen. It doesn't center it, and it doesn't scale it up. If you see here, there's some empty white space here and some empty white space there. What the new bit of code does is going to take this and it's going to center on the screen, and it's also going to scale it up to try to fit the screen the best it can. So let's see what the new code does, okay? So this is what the old code does. The new code should scale it up to try to best fit the screen, and it's going to center it. Also, the old code doesn't scale it if you resize the screen. So look, right now if I resize the screen, you see it stays the same size. Nothing happens. And I don't like that. I like for the game to fit perfectly on the screen, no matter what your screen size is. So if you say you create a game for a very high resolution, but somebody's in a browser which has a low resolution screen, it's just not going to look right. I don't like that effect. I like it to fit it in the best it can. So let's see what the new code looks like. Okay, perfect. So if you notice, the new screen almost looks the same, but if you see, it fits perfectly from corner to corner. It scaled it up to fit perfectly from end to end. There's not that empty gap in the corner like before. Now there's a little bit of empty gap on the top and the bottom. That's because it centered it on the screen and it left a little bit of empty space on the top and the bottom. Also, if I scale my browser up and down, it should scale the game up and down. So if I scale it, see, it scaled all the boxes to the new screen size, and it centered it. So it's got that little blank empty space in the left and in the right. It's centered it. Let me scale it again. Boom. If I rescale it again, it's scaled it to the browser. If it's from edge to edge, from top to bottom. So perfect. We're almost ready to start making games. This actually scales the game to best fit your browser and centers it on the screen. Okay, so we're almost ready, except for my first game, I want to implement one more thing. Let me show you. And my first game, I want to implement dialog boxes because the first game that I'm gonna make. I'm not sure if this is going to be the first or second game, but either the first or the second game that I'm going to make. Both games actually use dialog boxes, but one of the game is going to have network support. You're going to be able to play with other players over the networks, and it's going to display a dialog box saying that it's waiting for another player to join the game, and it's going to display a little dialog box saying it's your turn, it's his turn, things like that. So I want to implement dialog boxes, and also dialog boxes obviously are going to have buttons. Buttons where you press OK or where you press whether you want to play against a computer or whether you want to play against another human. So I want to implement dialog boxes, and I want to implement an object called TObject, and also I want to implement an object called TImage, which is going to display images, clickable images on the screen. That's not part of the TOEFL Vision library, but I'm going to add it because I use it a lot in games. So that's pretty much it. So we implemented everything up to application. At this point, we are ready to start making games. But before I make my first game, I want to implement T-Dialog. So that's going to be the next video.